All right. Okay, let's jump in and see what we have going on.
So for question 3, all we have to do, right, is type in the z-scores and then click on the sides that we need, right?
I'm not. Give me one moment. Let me get this. So let's see.
Isn't it both sides?
That's what I was thinking. It was like both sides, not the middle.
Yeah, it's just like to the left of that one, to the right of that one. So
To the right of that, and to the left of that.
Wait, do we like do middle left, or do we just do the left and then do the right, or do we do middle right and then middle
Well,
left?
let's see. So it says combined area under the curve that is to the right of the positive and to the left of the negative. So I guess it's just the middle.
Wait,
We're just
what?
doing the middle
So
of it. So we're just finding the area in the middle.
just the area in the middle.
Yeah.
So 0.826.
Let's see. 0.826. Yes, it is. Yep, that should be it.
Okay. This cannot be determined from the information given?
Well, it can. I'd say it's the second one, X bar, because to find the standard deviation for a random sample, it's the original standard deviation divided by the sample, the square root of the sample. So it would always come out as smaller. So X bar should be it. The distribution of the sample of means X bar for a random sample. So my guess would be that X bar.
that's the one I put earlier. I looked at the quiz.
So you put B?
Yeah, that's what I put, but I could be wrong.
Okay.
Almost confirms what I just said. Which of the following results implies that the spread in X bar decreases as the sample size increases? The normal, the central limit theorem, law of measurement. So it will be the central limit theorem. Will be my guess. I'm not confusing anyone, am I?
Mm-mm.
Hello?
No, you're not.
Sorry.
Oh, okay. I want to make sure everyone was frozen, so I was like, "Oh my gosh, it's going
No.
back."
I was talking to my roommate. I'm sorry.
Okay, good.
Say that one more time.
So, for which question?
Are we on 5?
Five
Or are we still on
or
4?
four?
Arnold, are we still on 4? Are we still discussing why it's B?
Yes. Or X bar. And for question 5, that it should I think it should be the central limit theorem.
It makes sense. Increases as the sample size increases. Okay. I mean, that makes sense to me.
Okay. Then question. Okay, so calculating the z-score is just normal z-score. Here's my calculator.
It'd be 9.2 divided by 8.8, right?
Wait, which one are you looking at? I'm looking at question 6.
Yeah. That's what I was looking at. I was just saying it was going to be 9.2 divided by 8.8.
So for question 6, it's going to be the standard deviation divided by the score that we are thinking of. Well,
Wait,
standard deviation minus the score divided by, I'm sorry, mean minus the score divided by standard deviation. That's what I meant to say.
Yeah, when you subtract the score and then the
So 150.8 minus 160
you get 9.2.
yeah.
divided by 8.8
is 1.045.
Yeah.
Right? Because I got 1.045 for the z-score.
Okay.
That's what I got.
Okay, that's what I got too.
Okay.
So 3 decimal places puts us at 1.045. I don't know if we're allowed to put a negative number because I got a negative number.
It's because
anyway.
when you find the z-score, it's the x, which is in this equation 160, minus the mean, which is 150.8, divided by the standard deviation, and you did it backwards. You did the mean subtract the x over standard deviation. That's how you got a negative number.
Okay, and it's the x subtracted. It's the x minus
subtract
the mean.
Yeah, x minus the mean over the standard deviation.
That is so weird because anyway. Well, I guess I got my stuff mixed up, but okay. All right, then the next one. What is the probability? So, randomly select the student who will have a score above that. Okay.
Is it 14.8 or 1.148? I don't know how to do that.
160 minus 150.8 divided by the mean, which is 8.8 divided by the square root of the number in question, right? I don't know why I'm spacing out right now on what I just.
Could you solve this problem by putting in the z-score in the normal probability applet and then clicking on the right-hand side? Or no?
I'm sorry, you were breaking up over there, so I did not hear any of that. Could you please repeat that?
Yeah, sorry. I said, could you plug in the z-score that we got from the last problem into the normal probability applet and then click on the right-hand side? Or can we not do that?
You can. I mean, it's the same z-score. Only difference is the sample size, the random sample is just one student. So dividing by the square root of 1 is still 1. So yes, since it says that would score above, so
I got 0.148 when I did that.
say that again.
My answer I got 0.148. I don't know if that's
Okay.
right.
So our z-score was 1.045.
Mm-hmm.
So put that in there. Okay, and the question wants above, someone who would score above that, right?
Mm-hmm.
So 0.148, is that what you get? You got?
Yeah, that's what I got. But is that what we're supposed to do? That's what I was asking. Like, could we do that? Is that? Because I mean, that's the probability. So.
Yeah.
Output.
Yeah.
Okay.
Okay. So I guess we will find the mean.
About 160 for the mean.
Say that again. Did you get 160
Yeah.
as the mean?
Mm-hmm.
Okay. Well, then I guess
How would we find the z-score without the Wait, do we have to find the standard deviation
I
as
did.
well?
5. What?
Do we have to find the standard deviation as well?
No, we're using the standard deviation of, I think this still includes the question that we've been doing, right? Did it say that?
Oh yeah,
We
the
need
next
to
four
answer the
questions.
next
Yeah.
4 questions. So yeah.
Yeah.
So 1, 2, 3. So yeah. So we just use a standard deviation of
Of 8.8. Okay, but then how are we supposed to find the z-score without? So we're just supposed to find a randomly selected one and select one randomly.
So the z-score should be 2.
2 point what?
2.338.
And how did you solve for that?
Okay, so since it's a random sample out of, a random sample being compared to the simple mean, it's going to be the mean minus the mean of the entire population, which is 150.8, divided by the standard deviation divided by the square root of the random sample, which is 5.
Why are we
So
doing the square root?
because it's a random sample, You're finding the z-score of a random sample
Oh, okay.
within another random sample.
Oh, okay.
Within a sample. Yes.
And that's how you got 2.338.
So in other words, the okay.
You're breaking up. I can't understand anything you're saying.
I'm sorry. Let me see. I think my internet connection is just not the best. Give me one moment.
Okay.
Vicky, can you pause it for just a moment? The internet connection is bad. Can you pause it? What? The internet connection is not good enough. It's breaking. Okay. Is it better?
Yeah.
Okay, excellent. So, okay, let's move on. All right, so 9, probably that 5 randomly for the test students will have a mean score that is greater than the mean achieved by the students in the previous problem. Okay, so the probability that 5 random students will have a mean score that is greater than the mean achieved by the students in the previous problem. So I guess we'll just take our z-score and just put it in the applet and
Okay.
find whatever is above that. 2.338.
Did you get
Okay.
0.009?
Yeah, well, it says to 4, yeah, for this one. So yeah, 0.0097.
So would that be 0.01?
It says round your answer to 4 decimal places. So no, it will
4.
just stay that.
Okay.
0.0097.
197.
Okay. Uh-oh. 15 questions. Yeah. Okay, so suppose the mean GPA. Okay, so the distribution is left skewed, or an example of that will be drawn. So what is the shape of the distribution? Well, so since it's a large sample, even though it's still random, the
normal.
Yeah, it will be normal. Then what is the mean of the probability of the sample means? Sample distribution. All samples of 81 that would be drawn from the distribution. So the mean is the same as the mean of the sample, the original sample. So 3.5. So what's it? Okay, a random sample. So it's another random sample. So we'd have to do the same thing that we just did.
Okay.
So the sample. So the sample size is 81. So let's see. So the mean is 3.5. The standard deviation is 0.7. random students is 81. And what is the standard deviation of the distribution? So the standard deviation is going to be the standard deviation that we have right now, which is 0.7 divided by the square root of 81.
Which is 9.
Okay, so the standard deviation should be 0.0, and it says to 3 decimal places, so 7, 8.
So it's 7.8.
0.078.
It says, wait, are we looking at 11?
No, 11 is the same mean as the sample mean, which is 3.5.
That's it?
Yep, that's it.
Okay. Okay.
And 12 is the one we just calculated.
Which is 0.007?
0.078, 3 decimal places.
0.078, okay.
So 13.
Be less than 3.3. Did we just plug in 3.5 for the wait? What was the Z score?
We didn't find the Z score. You can't really find the Z score on that one.
So how are we supposed to find the probability if we can't plug it into the?
Well, it's the Z score you plug in. So there's something else we plug in. So what is the probability that the mean GPA, which is 3.5 of randomly selected students, will be less than 3.3? Okay, I have to think about this one for a moment. So I guess, so we'll have to use this to find the Z score for 3.3 and plug that in and see the probability that will be less than that. So we have to find the Z score of 3.3 this time.
Okay, so would that be okay, hold on. So it's 3.3 minus 3.5?
Yep.
Divided by 0.7?
No, divided by the new standard deviation that we just found, which is 0.078.
Okay. Did you guys get negative 2.56?
Yeah. Okay, so what?
Sorry, I was yawning.
Okay. So the probability of that being less than 3.3 is 0.0052.
Okay,
I think
good.
they
That's what I got.
need 3 decimal places. So it's going to
0.005.
Is it? Yeah, 3. 0.05. Okay. What is the probability that the mean for anyone's is greater than 3.3?
Wait, okay, so if it's less than 3.3, we wouldn't do the middle and the left, would we? We would just do the left.
Yeah.
Okay. And then for the next problem, it's just the right side of it,
Yeah.
which is the same answer. Are you
No.
sure we're not supposed to do the middle?
Well, for this next one, we're doing to the middle, and it's everything after that, of everything on the right side. So it should be 0.9948.
Okay.
So 0.995. And for 15,
So basically what we have to do is find the z-score, plug it in, and then look at the areas under both sides of the z-score, not in the middle. Am I understanding that right?
I haven't really finished reading the question, so I'm still writing down the key points. Final
Okay.
probability that a random sample of passengers would have a weight that is as extreme or more extreme. So in other words, we're supposed to find the probability that a random sample of passengers will be more than 177.6. Probability that random sample of passengers. Okay, so we're supposed to find the z-score for this sample mean.
Mm-hmm.
And just find whatever is above that.
And below it. So we will do the edges, not the middle. If that makes sense.
Either above or below.
Or way below. It says, because the note, it says note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours in the positive direction. So it's like as low and as far away positive. So like it's both the ends. If that makes sense.
Okay. All right, well, let's get solving, I guess. So the z-score I got was 1.920.
What did you do for that? Because I got 1.068.
So I did the mean, which is 185 minus the new mean. Well, the new mean. Well, let me see, make sure.
177.6, right? That's what I did.
Yeah, divided by the standard deviation for the original sample, which is 26.7, divided by the square root of the sample size, which is 48. So unless my math is wrong.
You said, okay, so you did 185 minus 177.6, and then divided that by 26.7.
Yep, divided by the square root of 48.
Okay, and when I do that, I get a standard deviation of 0.04.
Well, that can't be that can't be right.
Okay, hold on, let me redo it.
And you should be getting a z-score, not the standard deviation.
Yeah, no, I'm going for the z-score. So
Yeah.
I get 7.4 for the top part, and then I divide it by 26.7, and I get 0.2771.
Okay, do 26.7 divided by the square root of 48. Then divide 7.4 by that answer.
I get 1.920.
Yep, that's what I got. Okay. So then I guess we put that in. And the two, if going by what you're saying, so the two ends gives us a probability of 0.0549. So
0.054. So 0.055.
Yep. Okay, that should be all. Who wants to volunteer as tribute?
I'll do it.
Okay. Let's see what happens.
We got 2 of them wrong.
Oh my gosh, which one?
We got 5 and 3 wrong.
Question 5 and question 3.
Yeah.
That is very unfortunate. Oh, well, I guess central limit theory. I guess I was wrong. Normal distribution.
That was my second guess, was normal distribution.
Decreases as the sample size increases. Okay, I'm gonna choose normal distribution on that. I will go next. But for question 3, let's see. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of that. Oh, and to the left of that. Oh, okay, my bad on that one. We're supposed to do just what we did right now.
Oh, okay.
Yeah, I confused everyone. That was my bad. So 1.358. All right, it should be 0.175.
0.175.
Okay, I'm gonna go.
Okay.
We had one wrong.
Which one was wrong?
Let's see. So question 3 was right, but question 5.
Okay. So question 3 was 0.175, correct?
Yes.
Okay. So 5. So it's
Question
not
5.
central. Is it law of large numbers?
I don't know, probably.
Katie?
Okay. I'm in my car. I'm gonna have to get closer to turn it in. My Wi-Fi is taking a second to turn back on. It just deleted all of my answers.
You deleted all your answers?
Yeah, so I have 30.175. And then 4 is the one with the X in the line. And then 5 is large numbers. 6, I don't remember.
1.045.
7,
0.148.
and then 8,
2.338.
2.33.
8.
Okay. And then 9,
0.0097.
and 10 is normal, and 11 is
3.5.
I have these all written down, but they're in my car. 12,
0.078.
13,
0.005.
14,
0.995.
and then 15.
0.055.
Okay, so question 5 is the one that we're trying to test. So,
Okay. I was trying to
Katie,
get
which
away
one
from
did you choose for question 5?
um, it looks like that's right.
Law of
Law of
large
large
numbers.
number.
Law of large numbers, yeah.
Oh,
We got
wow.
Okay.
Awesome.
Yep, got 100.
ouch.
Okay. So for next time, who wants to do for Monday?
So I was reading one of her things that she's having a class meeting at 7:30. We probably to listen to that on Monday. I think it's next Monday. Like a test review. So do you guys want to do this?
Wait,
Say
I
that
couldn't hear
again.
you breaking up.
Oh, do you guys want to do this earlier because she's having that thing at 7:30?
Yeah, I was actually gonna ask that. Is it okay if we do it at like 5:30?
I could try. I mean, I get off work at 4:30, so let's see if I can get home earlier. And then do it at 5:30.
Okay, we'll try.
Okay.
And if not, we can always try on Saturday.
That works too. All my homeworks are due on Saturday, but we'll see. What time on Saturday?
I'm free all day Saturday, so it doesn't matter.
No, I have homework until midnight, so it'll be good if we try it sometime in the evening because I usually start my homeworks at 12 noon and I keep going until around 6. So if you guys want to do Saturday, we can do it anytime after 6.
Yeah, that works for me because I get off work at 4:30, but that's Washington time, so that's 5:30 for you.
Okay. So Saturday at 6?
Saturday at 6 works for me.
Alrighty, who wants to do it? I can do it again if you guys want.
Okay, that's fine. You guys will have to explain to me next time. Do it.
Okay.
Okay,
Alrighty,
sounds
then
good. I'll
do
see
it
you guys
again.
Saturday.
Okay, we'll see you.
Bye.
Okay,
Bye.